Hey guys, what's up people? How are you guys doing? I hope all of you guys are doing good, taking care of yourselves. Welcome back to today's session. Welcome to Vedantu 9th and 10th English channel. I hope you guys are excited for today's session because I am super duper excited. My excitement is through the roof right now because we are going to talk about something very, very interesting today. But we're going to understand that with the help of another teacher from Vedantu 9th and 10th English channel, and that, my friend, is nothing but Bhavna ma'am. Let's say, guys, I want to burn a piece of paper. All right, I want to burn a piece of paper. I don't have a matchstick, neither do I have a lighter or any source of fire. How would I burn it? Now, if I was Bhavna ma'am, I could have used my evilness to convert it to energy, that is heat energy, and burn the paper. But I am no Bhavna ma'am, neither are you. So how will you do that? Okay, let me ask you another question. Can I use a lens to cause a fire? Possible? Yes or no? Let me know in the comment section. Let me know what you guys think about it. So very, very warm welcome to today's session. My name is Anoop. I am a master teacher of physics here at Vedantu. I hope you guys are having a fantastic, fantastic day. I am an aerospace engineer by profession and I've been teaching for past 5 years now. So that's a little bit about me. Apart from that, I am from Bangalore, but I was born in Kerala. So any Keralites out there, welcome. Hello, Cheta. Welcome. All right. So yeah, people, today's topic is going to be focus and standard incident rays of lenses. We are going to be talking about something very, very, very basic, which is going to help you to understand the next session much better. That is your ray diagrams and your, the lens formula, magnification and whatnot, right? So today's topic is going to be super duper important. So make sure you stay till the end and find out what Bhavna ma'am would do in order to catch that paper on fire. Yeah, I hope I'm saying it right. Anyways, so people, in the last session, I had asked you a homework question. I'll come back to all of these later. This was the question. Radius of sphere from which a lens is made up of is called as what? The answer, I know that you guys know the answer. It is nothing but the radius of curvature. Now, a couple of other notifications that I would like to start off with is, guys, we have a Telegram group for you people to get in touch with us, the master teachers, and you can also get the faster updates of all of the sessions that's going to happen, the regular schedules. All of it would be available to you, the weekly schedule. Everything would be up for grab for you guys if you come for this Telegram group, if you join this Telegram group. Now, it's totally free, so all you have to do is to download the Telegram app, put in this link, and you're a part of it, right? Now, apart from that, guys, we also have the Pro Exclusive micro course that is going on right now as we speak. This Pro Exclusive micro course is a chance for you guys to study with me on the Vedantu platform. I'll tell you how to do that. But for now, guys, there are two sessions going on. One is Be a Pro in Lens, bro, and Master Electricity like never before. These are the two concepts that we're going to be doing. So if you guys want to be a part of it, I'll tell you how to do that as well. Right. So with that said, people, let's get into the backtrack round. You guys know the drill. So what we're going to do is we are going to do a couple of questions from the previous session and check your level of understanding. Now, again, guys, it's not a live session, as you can see. So what I want you guys to do is write down the answers on a sheet of paper or keep that in your mind, but make sure that you cross-check your answers, because the more practice you get in these MCQ questions, the better you are going to get in your term 1 examinations. You're going to perform better in your term 1 examinations. So keeping that in mind, people, here's your first question for the backtrack round. Here it is. 30 seconds is what you get. The question is this. Dash is a lens that is thicker at the edges and thinner in the middle. Options are, is it a convex lens? Is it a concave lens? Is it a plane mirror, or is it something that you can't say? Jai Mata Ji. Jor se bolo. Jai Mata Ji. Yes. Come on, people. I'll give you another 6 more seconds. All those who haven't answered, please answer the question to yourself or in the in the chat box so that you can cross-check what your answer is, but do not miss out on any questions. Anyways, the answer to this question, if your concepts are clear, you would know it is nothing but a concave lens. A concave lens is one which is thin in the middle but thick at the edges, and convex lens is thin in the edges and thick in the middle. Right, next one. How many optical centers does a lens have? Does it have one optical center? What does it have? 2 optical centers, 3 optical centers, or 4 optical centers? Let's go, people. 15 seconds. Now remember, optical center is what, guys? It is nothing but the midpoint of the lens. It is nothing but the center of the lens. So how many optical center does a lens have? Your answer in 3, 2, 1. It is going to be 1, guys. A lens has only one optical center. Now, how many optical centers do you want a lens to have? It has only one. And right, the answer is 1. Here's another one. A lens is a transparent medium with a square shape with a triangular shape. Both surfaces curved surface. At least one curved surface. A lens is a transparent medium with a square surface, with a square shape, a triangular shape. Both surfaces are curved surfaces, or it has at least one curved surface. 5 more seconds, guys. Come on. If you need more time, people, pause the video and then answer the question. You can take all the time in the world you want to answer it, but make sure you answer it. I'll answer the question in 5, 4, 3, 2, 1. It should be option number D, guys. A lens is one which is transparent. Absolutely. It should have at least one curved surface. It is not necessary that both the surfaces has to be curved. It can have at least one. If it has at least one curved surface, then it is said to be a lens. That's all. Alright, guys, so that's it, people. Let's get into the topic for today. Let's figure out what Bhavna ma'am is going to do, right? Yes, girl. Let's go. Alright, here's the thing, guys. In the previous session, we had talked about refraction through a glass slab. So in a glass slab, you know that the light is entering from air into glass, undergoes refraction. And as the light is leaving, that is the emergent ray, is also going to undergo refraction, which is why you can see that the ray of light is slightly changing its path from the original path. So this is what the light was supposed to go, or this is the original path of light, but that is where the actual light ray is going. Now here also you can see that this is the original path of light, but you can see that it's again, taking a different path, or it's getting refracted, and that is why you see that refraction is very, very clear in a glass slab. But what about a lens? How does refraction look in that? See, guys, here's the thing. A lens is basically made up of glass, and glass is a different medium. So if a ray of light is coming from air and falling onto a lens, it is basically traveling from air into glass. So that's two different medium. One is air, the other is glass. And we know for a fact that the density of air is less and the density of glass is more. So glass is a denser medium. So a ray of light that is coming in incidenting on this glass will undergo refraction as soon as it enters the glass. That is where the first refraction happens. So you can see that it's clearly getting refracted. It is changing from its original path and basically moving a little downwards. Now, why does this happen? Because again, guys, if I draw a normal to this particular point, again, guys, the normal would be basically to the center of curvature. So if I draw a normal, you can see that it is going. Okay, let me just draw a normal to this side because there are two center of curvature, right? So let me just draw a normal to this point. So you see this, it is basically traveling towards the normal because the light ray is traveling from a rarer medium to a denser medium. Now here's the fact. As the ray of light is leaving the glass or the lens, it will undergo refraction one more time. So what's going to happen once again is that the ray of light is again undergoing refraction, and this time once again if I draw a normal to this point, you can see that it is traveling away from the normal. As simple as that. So there is two set of refractions happening when a ray of light is entering into a lens, and it's the same as a glass sphere. But here's the thing. When you talk about a convex lens, guys, it's not that just that one ray of light is going to undergo this. And the best part is when you extend this ray of light, you see that it will basically intersect at a point on the principal axis. Now you guys already know what a principal axis is. It's nothing but a straight line that is passing through the center of curvature as well as the optical center, both the center of curvatures. Now this particular ray of light which is parallel to the principal axis, can you guys see that? It's parallel to the principal axis. After refraction, it is going to intersect at a point on the principal axis. Now here's the thing, guys. If I take another ray of light, which is this time below the principal axis, this time this ray of light would undergo refraction and move upwards. And the best part is This ray of light will also intersect at a point on the principal axis. Once again, after refraction, they are both basically intersecting at the same point on the principal axis. Now, if I take n number of rays, 4, 5, 6, if they are parallel to the principal axis, after refraction, they will all meet at the same point. And this point in physics, in the world of optics, is what is called as the focus. So what is focus? Is nothing but a point on the principal axis where the rays of light parallel to the principal axis is meeting after refraction. As simple as that. It's the same exact kind of definition that we learned in mirrors before. Just that here it's refracting and not reflecting. So here's what it is. So your convex lens, guys, is called as a converging lens. Why? Because the rays of light are basically meeting at a point. They were all parallel to one another. But this convex lens is like Nokia phone. It is trying to bring people together. It is trying to bring all these lenses together. And you see that they are all meeting at the same point, which we termed as the focus. Now, guys, to answer that question, can Bhavna ma'am burn a sheet of paper with her evilness? No. But can she do it with a lens? Absolutely yes. Because here's the thing, guys. A lens, if a ray of light is coming from the sun, if you keep it under the sun, you have a paper beneath you. What's going to happen is that this magnifying glass would basically converge these rays of light like this one and make it all meet at a single point. And if you keep the paper exactly at the focus, since all these rays of light are meeting up at one point, the temperature goes up and the paper starts to burn. So yes, guys, that is the answer for that question. Now, people, here's the thing. The reason why I'm telling this is, guys, the rays that is coming from the sun, we're going to take it as, we're going to assume that these rays are parallel to one another. I'm not saying that all of the rays are perfectly parallel to one another, but we're going to assume that they are parallel to the principal axis and they're parallel to one another. And when they are parallel to one another, after refraction, they are all going to meet at the focus. And the distance between the focus the distance from the focus to the center of curvature, to the optical center, is what is called as the focal length. The distance from the focus to the optical center is what is called the focal length. As simple as that. Now to talk about a concave lens, people. Now it's pretty much the same in concave lens, but the fact is this. In a concave lens, you see that the ray of light is actually diverging from one another. So you see this, the ray of light is actually going away. It is saying Alvida and going forever and ever and ever. Now if I take another ray of light, you see that over here also it basically does the same thing where the rays of light are going away from one another. They're not meeting at all. So here's what happens. Here, when you extend the refracted ray, backwards, when you do that, you see that they will all appear to meet at a point. They're not actually meeting, but they will appear to meet at a point on the same side as that of the object. And that becomes the focus of a concave lens. Now here's the thing, guys. This is called as a virtual focus because the rays of light are not actually meeting at the focus. They're only appearing to meet. When you extend those rays of light, they are appearing to meet at a point on the focus. Whereas in the case of a convex lens, they are actually meeting at the focal point. So this is called as a real focus. This is a real focus. Whereas in the case of a concave lens, it's a virtual focus because the rays of light are not actually meeting. They're only appearing to meet. When you extend them, they will meet at a point on the principal axis, and that becomes the focus of a concave lens. Simple as that. Right, guys? Now, people, let me get into the most important topic for today. The standard incident rays of light. Now, here's the thing, guys. In order to do the ray diagrams, this becomes a lot difficult. Think about it, guys. Doing two different refractions on a glass, on a spherical surface, and then showing finding out the normal, and then doing all of this. It's a lot time consuming. It's a lot time consuming. So in order to do one ray diagram, you would take at least 10 to 15 minutes. In order to avoid all of this, we are going to use the standard incident rays. This is there in order to make your lives a little easier. And using these standard incident rays, my friend, you can draw any ray diagram. Does not matter if it's concave, convex lenses, you can do the entire ray diagram. Now, we've already talked about standard incident rays of your spherical mirrors. This is going to be a continuation of that. It is going to be pretty much the same, but here again, it's refraction and not reflection. So the first standard incident ray is this. If a ray of light is parallel to the principal axis, after refraction, this ray of light will pass through the focus. This is the first standard incident rays. And if you look at it, guys, you see that you're not showing two different refractions. You're just showing one single refraction in the middle of the lens. So here's the thing, guys, in your examinations also, you can just do one, you can just show one average refraction that happens rather than showing two different refraction happening in two different points. That is when the light is entering the glass and when the light is leaving the glass. Instead of doing all of that, you can just show an average refraction happening at the middle of the lens. So this way you will be able to save a lot of time and make your life a little bit more easier. Now, it's in no way it's wrong. In no way it's wrong, because this is how you will be following in your examinations as well. This is how the standard incident rays look like. So a ray of light parallel to the principal axis after refraction will pass through the focus. The second one, if it's a ray of light passing through the focus, if a ray of light is passing through the focus, then after refraction, my friends, it will become parallel to the principal axis. Once again, you're going to show the refraction happening in the middle, not here. Sorry guys, this is slightly wrong. It'll be at the middle, and you'll see that the ray becomes parallel to the principal axis. If a ray of light is passing through the focus, it'll become parallel to the principal axis. If a ray of light is parallel to the principal axis, after refraction, it will pass through the focus. And finally, guys, a ray of light that is passing through the optical center, it will pass through undeviated. Without any sort of deviation, it'll pass through straight. So these are the three standard incident rays. And using these standard incident rays, in the next session, we will be doing our ray diagrams. So please subscribe to the channel, so you can get a peek at that and understand the concepts a little bit more better, right? Now, apart from that, guys, if you talk about a concave lens, it's pretty much the same, just that here the rays of light are not actually meeting because it's a diverging lens, right? So you see this, after refraction, when you extend this ray of light, this a ray of light that is parallel to the principal axis will appear to meet at the focus, not actually meeting, because this is the refracted ray. It's only appearing to meet at the focus. And a ray of light that is appearing to pass through the focus, you can see this, a ray of light that's appearing to pass through the focus after refraction will become parallel to the principal axis. And finally, a ray of light that is passing through the optical center would pass through undeviated. And using these standard incident rays, people, we are going to be doing our ray diagrams. If you're still a little confused, guys, please take a screenshot of this one. A ray parallel to the principal axis, both concave as well as convex. For a convex lens, it'll pass through the focus. For a concave lens, it'll appear to pass through the focus. A ray of light that is appearing to pass through the focus after reflection will become parallel to the principal axis. And finally, a ray that is passing through the optical center would pass through undeviated, right, guys? So these are the three standard incident rays that you're going to be using in order to do your ray diagrams, right? So with that said, people, I am going to go with some quiz questions just to check if you guys have understood the concepts or not. But before that, guys, if you guys want to learn these kind of concepts in a fun and interactive manner, we are here for you guys, and you can absolutely register for the mega volt, that is Vedantu Olympiad litmus test for class 5th to all the way to class 12th. This is absolutely free for you people. The test is gonna start from 14th of August, so you have a couple of days left to prepare and be a part of it. If you guys do score good marks in this, you will be getting an amazing scholarship for this as well. So you'll be getting a good set of scholarship to prepare for your Olympiads. The test is exactly at 3 p.m. The registration link is right here. You can see that vdnt.in/megavolt-YT is what you have, and you can also get a chance to win an Amazon voucher of up to 17,500 rupees. A couple of more money and you can buy a PS5, people. Yeah, 17,500 rupees is what they are offering, what we are offering. So guys, what are you waiting for? Register for Megavolt. take a part in that and see if you guys stand a chance to win that 17,500 rupees. And also, guys, yes, good news for all the Vedants out there. So yes, guys, Vedantu has produced more than 120 state selections for NTSE Stage 1 for 2021 and 2020-2021, and this is across 17 states, and we are still counting the number of scholars who have ended up selected for the NTSE Stage 1. And yes, guys, apart from all of these, if you want to gain 100% knowledge, Vedantu is here for you guys, be it a long-term course to completely prepare for you guys, completely prepare for your board examination. And here at Vedantu, guys, we have streamlined our preparations such a way that it is going to help you for your term 1 as well as your term 2. So keeping your board exams in mind, we have basically designed our syllabus. So it ensures that you will not only gain 100% knowledge, but we also give you this guarantee that yes, your scores are going to improve. And if your scores does not improve, people, you can get your complete money back. And that is the promise that Vedantu is giving you people, so that you can basically have that success that all of you guys need. Because I'm sure that every one of you guys want to score good marks, but no institute in the world gives you the guarantee that that whether you score or not, how will you go about it? So here at Vedantu, we are giving you this guarantee that yes, your scores are going to improve, and if your scores don't improve, you can get your money back. And that is what we are doing here. We are taking away that pressure from your side so that you can focus on what's more important, and that is gaining the knowledge rather than running behind marks. Unlimited live sessions to ensure that you do that, with highest level of quizzes for your term 1 examinations, which gives you an opportunity to compete with your friends and understand where you're standing at that point of time. With that said, guys, it's quite hot here. Sorry about that. So yes, you can also get the chance to compete with your friends and see how good you are at the topic. You can also get interactive replays of all the sessions. So every single session is recorded. And while you're watching the replay, also you can check out the quizzes and check out the leaderboards as well. You get the premium content all downloadable in the form of PDF, so that you can refer to it whenever you want, with in-class doubt solving, with the highest quality of tests and assignments to ensure that you guys are on the right track. And yes, guys, unlimited number of micro courses for your stress relief management, for breathing exercises, for arts and crafts. So you're getting entrepreneurship. So you're getting a holistic improvement, not only which is focused on your CBSE syllabus, but something which helps you for life. That is what Vedantu is aiming for, right, guys? And if you want to be a part of it, it's quite simple. So let me just quickly show you how to be a part of that. Let me just skip this ad. Give me 1 second, people. Yes. Yeah. All right. Yes. Thank you. All right. So this is one of the videos that came out very recently. This was the previous session, that is spherical lenses and their competence. If you haven't checked that out, please do check that out as well. So click on show more, people. Go to subscribe to Vedantu courses right now. Click on this link, and this link is more than enough for you to enroll into any of the courses. And the best part is this link is also your way to get a flat 10% discount as well. Be it preparation for your NTSE, be it preparation for your 10th standard, whatever it is, you can select it from this particular page, right, guys? So if I say you want to prepare for your grade 10 examination, you see that there are 3 different types of courses offered at Vedantu. One is Vedantu Lite, the other is Vedantu Classic, and the other is Vedantu Pro Plus. Now, the features are a little different, but it's not much. But the kind of quality of education that you're going to get is going to be the same in all the 3. So do not panic about that at all. So in your Lite, guys, you'll get all the live interactive sessions, unlimited sessions. You'll have test series and assignments. You would have doubt solving inside the class, that too unlimited doubt solving, in time doubt solving. That is, whatever doubts you ask will be answered right there and then itself. But you can't download the Vedantu app. That is the only disadvantage that you have in Vedantu Lite. In Vedantu Classic, you have that option also to download the Vedantu app and get your doubts solved outside the session as well. In Vedantu Pro Plus, you have all of that, and you have something called as a personal mentor as well. Now, the personal mentor will ensure that you are getting the right sort of attention. He'll make sure that you're getting one-to-one sessions. So for all of your educational needs, your personal mentor would be that point of contact who will ensure that you are going in the right track, right guys? So the course price would be different for all of these. The 1 month program would be 2,340 rupees and the year-long program is 29,699 rupees. Now I know that a lot of us are from middle class family and the COVID-19 situation has only made things worse for all of us. So people, keeping that in mind, you don't have to pay the entire 29,699 rupees in one shot. You can pay that in EMIs. So monthly, you just have to pay around 2,475 rupees for the whole year. You can just pay month by month. And if you think about it, guys, even if you take it as 2,400 rupees, if I just take it as 2,400 rupees very quickly, if I do a very small calculation to show you the kind of value for money that you're getting, guys, for that 2,400 rupees, you're getting all the 6 subjects: physics, chemistry, bio, math, English, social science, all 6 subjects, which means that per subject you're paying about 400 rupees. And that is including your micro courses, including your Olympiad preparations, everything included. You have to pay just about 400 rupees for one subject. And if you talk about per session, in this 1 month, guys, in 1 month, you would have attended roughly about 150 to 200 sessions, right? That means that if I divide 2,400 divided by 150 rupees, that's basically, guys, about 10 rupees or 11 rupees per session, which is less than a cup of tea, to be honest. And you're getting the best of the best teacher. And you're also getting a promise from Vedantu that your scores are going to improve. Otherwise, you can get your fees back. No institution in the world will give you that kind of guarantee. And here it is at Vedantu, we're giving that. Right? So yes, guys, here's the top teachers who's going to be teaching you all of the, the timetable of the classes. You can check out the results that we've produced in the past. You can check out all of the testimonies from the parents and students, so that you can make a sound decision, right guys? So that's it. Let's get back into the topic. Let's do a couple of questions and see if we can get this right. So let's go, people. Here we go. So here is your first quiz question. 30 seconds again. Here it is. Let me know what is the answer, guys. The focus of a concave lens is what? Is it real, virtual, either real or virtual, or both real as well as virtual? The focus of a concave lens is what? Real, virtual, both real and virtual, or both neither real or virtual, or both real and virtual. Let's go. I'll start the quiz in I'll answer the question in another 5, 4, 3, 2, 1. The answer, guys, is virtual. For a concave lens, you have a virtual focus. For a convex lens, you would have a real focus. Next one. Which of the following statement is true? Geometric center of the lens is called as a pole. A lens has both surfaces flat. A lens has 2 foci, or a lens has 1 center of curvature. Which of these statements is true about a lens? All right. Another 10 seconds. Let's go, people. Geometric center of the lens is called as a pole. A lens has both flat surfaces. A lens has 2 foci, or a lens has 1 center of curvature. In 4, 3, 2, 1. The answer, guys, would be option number C, because yes, it has 2 center of curvatures and it'll have 2 focuses as well. So that is the answer, guys. That is the only statement that is true. The geometric center of a lens is called as your optical center. For a mirror, it's called as the pole. Last question, people. Here's another one. A ray appearing to pass through the focus after refraction will become what? A ray appearing to pass through the focus after refraction will become parallel to the principal axis, perpendicular to the principal axis. It'll pass through the focus, or it'll pass through 2f, that is twice the focal length. All right. A ray appearing to pass through the focus after a ray appearing to pass through the focus after refraction, which is appearing to pass through the focus after refraction, will become parallel to the principal axis. A ray that is parallel to the principal axis after refraction will pass through the focus. A ray that is appearing to pass through the focus after refraction will become parallel to the principal axis. And that is in the case of a concave lens. In the case of convex lens, it will actually pass through the focus, right? And after refraction, it will become parallel to the principal axis. One more question, guys. Sorry about that. Here's another one. A ray of light passing through the optical center goes parallel to the principal axis, goes through without any deviation, passes through the focus, or can't see. A ray that is passing through the optical center goes parallel to the principal axis, goes through without any deviation, passes through the focus, or can't see. I'll answer the question in another 5 more seconds. If you need more time, pause the video and then answer it. In 4, 3, 2, 1. The answer, guys, would be option number B. A ray of light that is passing through the optical center will pass through without any deviation. And this is your homework, guys. Go ahead, do this homework question. Let me know what is the answer in the comment section. The question is, when a parallel beam of light falls on a convex lens, it does what? Let me know what is the answer in the comment section. Super duper easy question. And again, guys, if you want to enroll into the pro exclusive courses, all you have to do is click on the link that I just showed you, that I just talked about. Enroll into the pro subscription courses, and once you enroll into the pro subscription courses, you can automatically be a part of the pro exclusive micro course as well. You will find it and you can be a part of it, and we can have an amazing time throughout the year, right? So thanks a lot for joining, guys. I'll catch you guys in the next one. Until the next time we meet, this is Anoop signing off. Have a great day ahead, and do not forget to like, share, subscribe. It gives us a sort of motivation to give you guys some amazing content in the future as well. Thanks a lot for joining. Catch you guys in the next one. This is Anoop signing off for the day. Have a great day ahead, guys. Bye bye. See you all.